Good morning, students. Okay, come back to maths class. Today we'll start new chapter, three-dimensional geometry. Already first year in over three introduction to three-dimensional geometry. Only based on distance formula and section formula only. Okay, introduction to three-dimensional geometry is over in first year. In this second year, three-dimensional geometry start with only direction, cosines and direction ratios studied in three-dimensional geometry, direction, cosines and direction ratios. Next, equation of a line. In equation of line passing through the points, derive the theorems. Derive the theorems and equation of line passing through the point and parallel to the vector, and find the equation of line passing through 2 points, angle between two lines, and shortest distance between two given lines in equation of line. And we'll study in this chapter equation of plane. Equation of plane. Okay, derive the equation of plane in normal form. Okay, derive the equation of plane passing through the point and perpendicular to the vector. And derive the equation of plane passing through three non-collinear points. Intersection between two planes. Okay, co-polarity of two given lines. Okay, and distance of the point from the plane, then find. Okay, this is to study in this chapter. Okay, today in this chapter, weightage for this chapter is 1 mark 1 question, 2 marks 1 question, 3 marks 1 question, 5 marks 1 question. Total 11 marks. 1 plus 2 3, 3 plus 3 6, 6 plus 5 11. Okay, total 11 marks. In this chapter is also very important in KCT and JEE also. Okay, minimum 3 questions will get. Okay. Today first we will do some introduction part to discuss first. After that we study direction ratios and direction cosines. First study introduction. Introduction part. Rectangular Cartesian coordinate system in three-dimension space. Three-dimension space. Okay. First, you have to consider three mutually perpendicular lines. X, Y, Z. Okay, intersecting at origin. Okay, consider three mutually perpendicular lines, XOX dash, YOY dash, ZO Z dash. Okay, these three mutually intersecting at the point O. The three mutually perpendicular lines are called rectangular Cartesian coordinate axis. Rectangular Cartesian coordinate axis. The line XOX dash is called x-axis. The line YOY dash is called y-axis, and ZO Z dash is called z-axis. The point O is what? Origin. Okay. The plane containing y and z axis. Y and z axis is called YZ plane. Is called YZ plane. Next, the plane containing z and x. The plane containing z and x axis is called ZX plane. is called ZX plane. And last, the plane containing X and Y axis. The plane containing X and Y axis is called XY plane. Is called XY plane. Okay, these three planes are mutually perpendicular to each other. XY plane, YZ plane, ZX plane are what? Mutually perpendicular to each other and are known as coordinate plane. And are known as coordinate planes. Okay, these coordinate planes are divided into 8 regions. Divided into the space 8 regions called octants. Okay, these planes are divided the space into 8 regions called octants. Okay, next the octant having OX, OY, and OZ as its edges sides. Okay, is denoted by OX, Y, Z. Okay, often having OX, OY, OZ as its edges is denoted by OX, Y, Z. This is what? First octant. This one is what? First octant. First octant. Total 8 reasons you get. One by one we will study. First one O X Y Z. Okay. In OX dash is X value is negative, inside Y is negative, Z is negative. Okay. Second one OX dash Y Z. OX dash Y Z. OX dash Y Z. Next to this one OX dash Y dash Z. OX dash Y dash Z. OX dash Y dash Z. Next X dash is remove that. This three one. OX Y dash Z. OX Y dash Z. This one is remove that. OX Y dash Z dash. Y dash Z dash. Y dash is remove that. OX Z dash Y. Then write first Y. OX Y Z dash. X is remove that. O Z dash. O Z dash Y X dash. O X dash Y Z dash. Okay. Next Z dash. O X dash Y Z. Z dash remove that one. O X Y Z already is there. Okay. O X dash Y Z already is there. Last one is all are negative. O X dash Y dash Z dash. Check it. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 reasons we get. In first one, coordinates are what? X, Y, and Z coordinates octants. These are the octants. In first term, in this octant, X is positive, Y is positive, Z is also positive. In second, in this octant, X is negative, Y is positive, Z is positive. In this one, X is negative, Y is negative, Z is positive. Next, X is positive, Y is negative, Z is positive. Next, X is positive, Y is negative, Z is also negative. X is positive, Y is positive, Z is negative. Next, X is negative, Y is positive, Z is negative. In last, all are negative. Okay. First, in this one, OXY, positive, positive. In this one, negative. Okay, x dash, 1x dash, next another 1x dash, 4 negative, 4 positive in the coordinate axis. 4 positive, 4 negative. This is the rectangular Cartesian coordinate system in 3-dimensional space. This is the introduction part. Okay, next already we have studied in first year distance formula and section formula. At some remarks, note. First one, distance formula. Distance formula. Distance between the points P and Q are A and B. The distance between the points. P of x, x1, y1, z1 and q of x2, y2, z are A point, A, B points. Then PQ is equal to our distance between 2 points PQ root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 square. Already put this result in first year, distance between the points A and B. Second, section formula. Let the point P, which divides the line joining the points AB. P point is XYZ. P of XYZ divides the line joining the points. A of x1, y1, z1 and B of x2, y2, z2. Internally in the ratio m is to n is what? P of xyz is equal to mx2 plus in vector algebra already I am telling OP vector is equal to MB vector m into B vector plus n into A vector divided by m plus n internally. Okay. OP vector means what? Xi plus yj plus zk is equal to m into B vector is what? x2i plus x2 y2j plus z2j, and next is comparing the corresponding components, then we will get this result. Okay, divided by m plus n, comma my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus n. This is section formula for internal division. Next is this one is first. In second, externally in the ratio m is to n. Same one, P of xyz is equal to mx2 minus mx1 divided by m minus n. my2 minus ny1 divided by m minus n. mz2 minus nz1 divided by m minus n. This is section formula for external division. Third one, P be the midpoint of the line joining the points A and B. Same. This P is the what? Midpoint of the line joining the points A, B. Midpoint formula. Okay. P of x, y, z is equal to x1 plus x2 divided by 2, or x1 plus x2 divided by 2, or x2 plus x2 divided by 2. y1 plus y2 divided by 2, comma z1 plus z2 divided by 2. This is midpoint of the line bearing the points A and B. P is the midpoint. In last, G is the centroid of the triangle. Centroid of triangle formula. Centroid of triangle. Centroid of triangle. G is the centroid of the triangle. Okay, with vertices A point x1, y and z1, B point x2, y2, z2, and C point x3, y3, z3. x1 plus x2 plus x3 divided by 3. y1 plus y2 plus y3 divided by 3. z1 plus z2 plus z3 divided by 3. This is centroid of the triangle with vertices A x1 and z1, B x2 y2 z2, and C x3 y3 z3 is given by G is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 divided by 3. Okay, this is totally introduction. Already we have studied in first year this one, this concept, distance, section, midpoint, and center of triangle. Next we will study direction cosines and direction ratios. Actually in this chapter start with direction cosines and direction cosines. Direction cosines and direction ratios. Already we will study in vector algebra, direction cosines and direction ratios. On that chapter, when vector is given xi plus yj plus zk, components form is given, then find out direction cosines. Direction cosines are what? Cos alpha, cos beta, cos gamma are the direction cosines. Then defined by x by r, y by r, z by r. Okay, L is equal to x by r, m is equal to y by r, z is equal to n is equal to z by r. Same. Ratios are what? X, y, z are the ratios. Okay, direction ratios ABC. Okay, in this chapter, direction ratios are given. Then find out direction cosines. Angles are given alpha, beta, gamma. Then find out direction cosines. Okay. Consider a three-dimensional space. Consider first three-dimensional space. Let AB vector be a directed line segment. Let AB vector be a directed line segment. Okay. Next, let OP vector be the directed line segment through the origin O. Through the origin. Okay. and parallel to AB vector. OP is what? Parallel to AB vector. Okay. OP is equal to magnitude of OP is equal to magnitude of AB vector because parallel same. Okay. Magnitude of OP vector is equal to magnitude of AB vector. Then first we have to consider that AB vector be the directed line segment in the space, in three-dimensional space. Next, let OP vector be the corresponding directed line segment. OP vector be the corresponding directed line segment. Okay, and parallel to AB vector. AB vector. Okay, this means OP is parallel to AB. Then magnitude of OP vector is equal to magnitude of AB vector. Magnitude of OP is equal to magnitude of. Next, alpha, beta, gamma are the angles made by the line OP vector. With positive directions of x-axis, y-axis, z-axis respectively. Then cos alpha, cos beta, cos gamma are the direction cosines. And usually denoted by what? L, M, N. Okay. The direction cosines are made by what? OP vector and hence AB vector also. Okay, same OP is equal to what? AB. The direction cosines of directed line AB vector are LMN. The direction cosines of the directed line AB vector are LMN. Then the direction cosines of the directed line BA vector opposite. BA vector are what? Minus L, minus M, minus N. Okay. Next, the unit vector I make angles. You know already. Unit vector I make angles alpha, beta, gamma. Now we are taking. Alpha is what? 0. Same. Unit vector I make angles 0 degree. Others are not perpendicular. Mutually perpendiculars are there. I, J, K are unit vectors or mutually perpendicular unit vectors. 0, 90, 90. Okay. Unit vector I cap. Okay, the unit vector I cap make angles 0, 90, 90 respectively with x-axis, y-axis, z-axis. Okay, the direction cosines of I are cos alpha, cos beta, cos gamma. This one alpha, beta, gamma. The direction cosines of I are cos 0. Cos 0 is what? 1. Cos 0 is 1. Cos beta, cos 90 is what? 0. Cos gamma is also 90. Then 0. Therefore, in fact, that the direction cosines of any vector along x-axis are what? 1, 0, 0. Direction cosines of y-axis. Now we are make angles 90, 0, 90. Y, J. First I means what? Same we are taking 0. Others are perpendicular. 1, 90, 90. Next unit vector J cap you have to take. Next is what? I to J, now 90. Next same J means what? 0. Next 90. Now direction cosines of y-axis are what? 0, 1, 0. Direction cosines of this one is x-axis, this one is y-axis, and direction cosines of first make angles 90, 90 and 0. Okay, unit vector along unit vector k क्या make angles 90, 90, 0. Cos 90, 0, cos 90, 0, cos 0 is 1. This one is what? Direction cosines of z axis. Direction cosines of z axis. In 1 marks very important. Already 2-3 times asking. Write the direction cosines of x axis. What? 1, 0, 0. Direction cosines of x axis. This one is direction cosines of y axis. This one is direction cosines of z axis. Okay, this one is what? Direction cosines. Direction ratios, the numbers a, b, c are x, y, z. The numbers a, b, c which are proportional to the direction cosines are what? Element of a line is called as direction ratios of a line. First, direction cosines. Let AB vector be a directed line segment. Write down that AB vector be a directed line segment. Directed line segment in the space. In the space. Okay. Next, let OP vector be the corresponding OP vector be the corresponding directed line segment through the origin O, through the origin O, and parallel to AB and parallel to AB vector Next, the OP is parallel to AB, that is OP is parallel to AB. AP is parallel to AB. This implies magnitude of OP vector is equal to magnitude of AB. Next, alpha, beta, gamma are the angles made by OP vector. Like alpha, beta, gamma are the angles made by OP vector. Alpha, beta, gamma are the angles made by OP vector, and hence of what are the angles made by OP vector with positive directions of x, y, and z axis respectively. Then cos alpha, cos beta, cos gamma are the direction cosines of. Then cos alpha, cos beta, cos gamma are the direction cosines. Direction cosines of OP vector. OP vector and hence the AB vector. And hence the AB vector. And usually denoted by LMN. And usually denoted by what? LMN respectively. Okay. Next, the direction cosines of directed line AB vector are the direction cosines of directed line. The directed line AB vector are LMN. Then the direction cosines of next, the unit vector I make angles. The unit vector I make angles. First 0, 90, 90. Others are what? Perpendicular. 0, 90, 90. With respectively with what? Respectively with x-axis, y-axis and z-axis. X, y and z-axis. Okay, respectively with x, y and z-axis. The direction cosines of I are the direction cosines of I are cos 0. Direction cosines of I cap are what? Cos 0, cos 90, cos 90. First angles is what? 0, 90, 90. 0 means what? Same you are taking 0. Others are perpendicular. Okay. Now cos 0 is 1, cos 90 is 0, cos 90 is also 0. Cos alpha, beta, gamma. Okay, cos 0, cos 90, cos 90. Direction cosines of I cap are 1, 0, 0, 0. Okay, next, in fact, the direction cosines of any vector along x-axis. Any vector along x-axis are one, 0, 0. Same in x-axis angles are what? 0. Others are perpendicular 90, 90. Okay, x-axis are 1, 0, 0. Similarly, the direction cosines of y-axis are, make angles first. The unit vector J make angles 90. First one is what? This means alpha. other, this one is what? Y is perpendicular to x. Okay, J is perpendicular to R. This one is 90, 0, 90. Okay, now y-axis are what? 0 means cos 90 is 0, cos 0 is 1, cos 90 is 0. Okay, and the direction cosines of z-axis are, the direction cosines of z-axis are 0, 0, 1 because the unit vector k cap make angles are what? 90. This one also. This one is what? 0. Same. Others are perpendicular. 90, 90, 0. Okay. Cos 90 is 0. Cos 90 is 0. Cos 0 is 1. Okay. Very important in 1 mark. Write the direction cosines of x-axis. Okay, direction cosines of x-axis 1 0 0, y-axis 0 0 0 1 0, and z-axis are what? 0 0 1. Next, last, direction ratios. Direction ratios. Direction ratio. Three numbers A, B, C. Three numbers A, B, C or x small x, y, z, which are proportional to the, which are proportional to the direction cosines, to the direction cosines, direction cosine proportional to the direction cosines LMN, okay, of a line. Direction cosines LMN of a line, LMN of a line are called direction ratios. Direction ratios of a line. Okay, these are direction cosines and direction ratios. Direction cosines are LMN. This means cos alpha, cos beta, cos gamma. And direction ratios are ABC, small ABC, or XYZ. Okay, only XYZ or ABC. These are the direction ratios. Next, one theorem is there. If L and N are the direction cosines, if L, M, N are the direction cosines, LMN are the direction cosines of a line, then L square plus m square plus n square is equal to 1. Then prove what? Element are the direction cosines of a line. Then n square plus n square is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is also 1. Because element are what? Cos alpha, cos beta, cos gamma. Prove. This condition you have to use it in problems only. In theory and CD also. First, we will draw the three-dimensional space. Okay. Let L be the directed line segment in the space whose direction cosines are L, M, N. L, M, N. Or AB you have to take it. AB and OP. Previous I am telling already in direction cosines. L be the directed line segment in the space whose direction cosines are dimension L, M, N. Next, let L dash be the corresponding directed line segment through the origin O. Through the origin O. Through the origin what? O. Okay. Next, say alpha, beta, gamma are the angles made by the line L dash. Made by the line L dash with positive directions of x-axis, y-axis, z-axis. Then cos alpha is equal to what? L. Next, cos beta is equal to what? M. Cos gamma is equal to what? N. Okay. Next, let P of x, y, z. P of x, y, z be the point on L dash. P of x, y, z be the point on L dash. Whose quotient vector is what? R. Then OP vector is equal to xi plus yz plus zk. Okay. Next is P of x, y, z be any point be the point on L dash. Then OP vector is equal to what? Xi plus yj plus zk. This means magnitude of OP vector is equal to what? OP root of x square plus y square plus z square. Okay, magnitude of OP is what? Root of x square plus y square plus z square. Next, we will draw PM perpendicular to y-axis. Next, we will draw PM perpendicular to y-axis. PM perpendicular to y-axis. Now, from the right angle triangle OMP, right angle triangle OMP, right angle triangle. Okay, this means OM is equal to y. OM is equal to what? Y you are taking. OM is equal to y. Now, angle POM is equal to y. POM is equal to what? Beta. POM is equal to what? Angle is what? Beta. Angle POM is equal to beta. Then cos beta is equal to what? Cos means adjacent divided by hypotenuse. Adjacent is what? OM. OM divided by OP. OM divided by OP. This means cos beta is equal to OM is what? Y. P OP as is. Cos beta is equal to Y by OP. Okay. Similarly by perpendicular we have to the x-axis and z-axis. Now you have to draw PM perpendicular to what? Y-axis in this. This one is what? PM perpendicular to y-axis. Next, similarly, PM perpendicular to x-axis and y and z-axis and z-axis. By drawing perpendicular to what? X-axis and z-axis. Already y-axis is over. Then you will get, then x means what? Angle alpha. Y means what? Beta. Next z is what? Gamma. Now cos alpha is equal to what? Y in place. Same hypotenuse is same. OP. Now x divided by OP. Then cos gamma is what? Z by OP. Cos beta is Y by OP. Cos alpha is what? X by OP. Cos gamma is Z by OP. Cos beta I can written as what? M. L already I am telling cos alpha is equal to L. Cos beta is equal to M. Cos gamma is equal to what? N. Okay, this one is what? Cos beta can be written as M. Cos alpha means what? L. Cos gamma means what? N. Okay, L is equal to X by OP. M is equal to Y by OP. And N is equal to Z by OP. Okay, L, M, N. Therefore, you are taking LHS, then prove L square plus M square plus N square. L square plus M square plus N square. L is what? X by OP. X square by OP square. Next, Y square by OP square. N is Z by OP, Z square by OP square. LCM is same, numerator is X square plus Y square plus Z square. Whole divided by OP square. X square plus Y square plus Z square, or X square plus Y square plus Z square is what? OP square. You know this. OP is equal to root of X square plus Y square plus Z square. Then OP square is X square plus Y square plus Z square. This is OP square divided by OP square. Cancel. Okay, because OP is equal to root of X square plus Y square plus Z square. Okay, this is the condition. L square plus M square plus N square is equal to 1, or cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, it's very important in this condition. Okay, tomorrow I will do this once again. Okay, start this. Thank you.